Okay, let's dive in. Imagine, if you will, ancient texts describing actual flying machines. I mean, not just myths, but machines with, like, specific parts, strange materials, even down to the measurements.
Yeah, it's pretty extraordinary. And that's really the claim right at the heart of this text, the Vaimanika Shastra. It basically says it holds the secrets to ancient Indian aeronautics.
Exactly. So today, we're doing a deep dive into this, well, this really fascinating document. And we're going to focus specifically on just one of the flying machines it talks about, the Shakuna Vimana.
And I think it's really crucial right from the start to be super clear about what we're looking at. Our source today is a very specific English translation. It's the one done by G.R. Josier, published back in 1973.
Okay.
Now, that translation is based on a Sanskrit text, which was apparently dictated by a Pandit Subbaraya Sastri. This happened between 1918 and 1923.
Right.
And he said this knowledge came from the ancient sage Bharadwaja and, other famous rishis from way back when.
So for today, just to be clear for everyone listening, we're sticking only to this 1973 Josier translation as our main source.
Absolutely. We're exploring what this specific text says about the Shakuna Vimana. We're looking at the descriptions, the materials, how it supposedly works.
And we're kind of putting aside the bigger debates for now, like, is it really ancient? Where did it really come from?
Exactly. For this deep dive, we're focusing just on the document itself, what's written on the page.
Got it. So the mission is clear. Understand the Shakuna Vimana, but purely through the lens of this one text. We want to pull out all the little details, the nuggets it gives us about this supposed design. Like, what parts does it actually list? Are there exact dimensions? What materials does it say to use? And what does it tell us, or maybe just hint at, about how it was built or how it flew?
Yeah, we're peeling back the layers of the document, essentially, trying to see the technical picture it's painting of this particular flying machine.
It's like textual archaeology almost.
Yeah. In a way, yes. It's an in-depth look at the descriptions, the specs, the mechanisms that are presented inside this quite unique and very technical sounding text.
Okay, so where do we start? Maybe some background on the Vaimanika Shastra itself, as our source presents it. It wasn't just a standalone thing, was it? It claims to be part of something bigger.
It does, yeah. The forward and preface in Josier's translation frame it as just one chapter, the 40th chapter, apparently of a much, much larger work. This bigger work is called Yantra Sarvasva.
Yantra Sarvasva. What does that mean?
It translates pretty directly as all about machines, or maybe the omniscience of machines.
Wow. Okay.
That's ambitious.
Incredibly ambitious, right? It immediately gives you a sense of the huge scope being claimed. And the Vaimanika Shastra part itself, the text describes it as being nearly 6,000 lines long, or maybe 3,000 Sanskrit verses.
Which is the part dictated by Pandit Subbaraya Sastri over those years, 1918 to 1923.
That's the one. Attributed, as he claimed, to Maharshi Bharadwaja and others. Yantra Sarvasva, all about machines. Just thinking about that title, it suggests aeronautics wasn't seen as some separate weird thing, but just one part of a whole science of mechanics or technology.
Right.
At least according to this text's claim.
That seems to be the implication, yes. A comprehensive framework.
And within that framework, the text actually classifies the Vaimanas, these flying machines. It groups them based on different cosmic ages, or yugas. I think that's in chapter 6.
Yes, that's a really key part of how the text structures its own information. Chapter 6 lays out this classification system, tying the types of Vaimanas to the traditional Hindu epochs, the yugas. It describes 3 main types.
Okay, what are they?
First, you have the Mantrika Vimanas. These are said to be from the earliest age, the Treta Yuga. Now, these are presented as machines that weren't operated by, like, levers and buttons, but through deep knowledge and use of powerful hymns or mantras.
Wow. So flying using sound or vibrations or spiritual energy.
That seems to be the idea presented in the text, yeah. A technology powered by mantras. The source says there might have been 25 or even 32 different kinds of these, including the famous Pushpaka Vimana you hear about in other stories.
Okay, Mantrika from the Treta Yuga. What comes next?
Moving forward to the next age, the Dwapar Yuga, the text describes the Tantrika Vimanas. These, it says, were built and flown using tantric knowledge.
So a different kind of specialized, maybe esoteric knowledge.
Seems like it. The text lists 56 types in this category, giving names like Bhairava, for example.
Right, from mantras to tantras. Which brings us to, well, the current age, according to the text.
Yeah.
The Kali Yuga.
Exactly. And according to this text, in our current age, the Kali Yuga, the power or maybe the understanding of mantras and tantras has declined.
Okay.
So the Vimanas that are suitable for this age are called Kritaka.
Kritaka. What does that mean?
It translates most directly as artificial or mechanical, things that are made constructed.
So the Shakuna Vimana we're focusing on fits in here. It's presented as a machine, something built and operated mechanically, not through chance or rights.
That's the clear distinction the text makes. Sutra 4 in chapter 6 is pretty direct about it. It says Shakuna and 25 other types of Vimanas are Kritaka.
And it lists others too.
Oh yeah, it lists quite a few others alongside Shakuna in this Kritaka group. Names like Sundara, Rukma, Mandala, Vakratunda, Padraka, lots of them. It reinforces that the Shakuna belongs to this class of, well, seemingly more tangible, buildable machines as described in this source.
That's such a fascinating framework the text sets up. Linking the type of technology to the spiritual or intellectual state of the age. It adds this whole philosophical layer to the technical bits that come later for the Kritaka types.
It really does. It sort of sets the stage, doesn't it? Presenting the Kritaka Vimanas, and therefore our Shakuna, as the kind of advanced aerial tech that's supposedly possible and buildable now, according to the text's own narrative.
Okay, so Shakuna is established as Kritaka artificial, mechanical. Let's look at the name itself then, Shakuna. You mentioned that means something specific.
Yes. Shakuna is Sanskrit for bird.
A bird.
Yeah.
Okay, that's pretty suggestive for a flying machine name.
It is striking, isn't it? Now, here's where we need to be careful. The text names it Shakuna, obviously implying a link to birds. And the source publication, the Josir book, does include illustrations labeled Shakuna Vimana. And yeah, they show big wings. However, there's a commentary in the preface of the book, which is sort of outside the main dictated text itself. And that commentary is actually quite critical of those drawings. It calls them absurdly unaerodynamic and looking like brutalist wedding cakes with huge ornithopter wings.
Oh, really? So the drawings might show wings, but maybe they aren't reliable, or at least the commentator didn't think so.
Well, the key point for our deep dive, sticking to the text itself, is this. The actual detailed description of the Shakuna Vimana's parts and structure, which starts on page 91, doesn't really explain why it's named after a bird. It gives the name, but then
it describes something else.
Exactly. Crucially, in that detailed description of the components and how they might work, the text doesn't actually describe flapping wings as the main way it flies. It uses the bird name, then describes the structure and mechanics in a very different way.
Okay. That's a really important point for us and for you listening. The name suggests bird. The pictures might show wings, but we're going by the words on the page in the main text.
Yeah.
And those words describe the parts and function differently.
Precisely. Stick to the textual description. The text gives the name, and then it gives us what reads like a technical blueprint.
And when it starts describing how to build the Shakuna, what's the first thing it specifies? The material.
Yes, it immediately gets into the primary material. It's specified repeatedly as Rajaloha.
Rajaloha.
Sutra 5 of chapter 6 on page 90 states very clearly that Kritaka Vimanas, including the Shakuna, should be built out of Rajaloha. And then it says it again when describing the Shakuna itself on page 91.
Rajaloha. I've heard that translated as king metal or something similar.
That's a common translation, yes.
So the text goes from classifying the machine based on its era and operating principle right down to the specific stuff it needs to be made from.
Yeah.
That feels like a definite step towards, well, what it claims to be, a kind of construction manual.
It does. It gives a very specific material requirement right up front for this type of Vimana. It grounds the concept in a physical substance, even if that substance is described in ways we'll need to unpack.
Right. Let's get straight into that then. The real nitty-gritty technical descriptions. What does this source tell us the Shakuna Vimana is actually made of? Part by part. Measurement by measurement.
Okay, so the description, which you'll find on pages 91 and 92 of the Josir translation, it starts right at the bottom with the foundation. It calls this the pitha.
Pitha, like a base or platform.
Essentially, yes, the base plate or foundation. And the text gets incredibly specific with the dimensions for the Shakuna's pitha. Height, 80 feet. Length and breadth, 56 feet each.
Hold on, 80 feet high for the base plate? That's enormous. Like an 8-story building just for the base.
That's what the text states. 80 feet high. And 56 by 56 feet in length and breadth. But then it adds a detail. The height is 70 feet on the north and south sides.
Huh. So not a simple block, maybe sloped sides or something. 80 feet high overall, 56 by 56, but only 70 feet high on two sides.
It suggests a complex shape, doesn't it? And it also says the tip should be three-cornered.
A three-cornered tip on an 80-foot-high base. That's incredibly specific and, well, hard to picture exactly. And this whole massive base is made of...
Rajaloha. Explicitly stated again, the pitha must be made of Rajaloha.
Okay, so this huge, complex Rajaloha base was built on top of it.
Rising from the pitha is the central mast. The text calls it the Nalastamba.
Nalastamba.
It specifies that this mast is hollow, and just like the base, it's also made of Rajaloha. Its height is also pretty impressive. It matches the base height, 80 feet tall.
Another 80 feet. So the mast rises from the 80-foot base, or is the total height 80 feet? The text says the pitha height is 80 feet.
That's a good point of clarification. Page 91 says its height is 80 feet, referring to the pitha. Then a hollow mast called Nalastamba, its height is 80 feet. It could mean the mast rises 80 feet from the top of the pitha, making the whole thing 160 feet, or perhaps the total height, including the base integrated with the mast, is 80 feet. The phrasing fixed to the pitha might suggest the latter, but it's slightly ambiguous. Let's assume for now the mast itself is described as 80 feet high.
Okay, let's go with that. An 80-foot-high, hollow Rajaloha mast. What else does it say?
It gets really detailed about the mast's diameter and how it changes as you go up. At the bottom, where it meets the pitha, the outside diameter is 35 feet, and the inside diameter is 30 feet.
So thick walls at the base, 5 feet thick.
Seems so. Then in the middle section, the outside diameter narrows to 25 feet, and the inside to 20 feet, still 5 feet thick.
Okay, tapering inwards.
And then higher up, the outside diameter is 20 feet, and the inside is 15 feet, still maintaining that 5-foot wall thickness.
That level of precision, giving the taper inner and outer diameters at different points, it's remarkable. It really does sound like reading off an engineering drawing almost. How is this huge mast connected to that complex base?
The text uses a specific phrase, fixed with a screw joint. That's how this big, tapering hollow mast is apparently joined to the pitha.
A screw joint for something that massive.
Okay.
Now, you said the mast is hollow. Is there anything inside it?
Yes, and this is where it gets really fascinating and maybe a bit strange. Inside this hollow mast, the text describes a system involving 6 wheels, and it states their purpose very clearly in order to adjust the airspeed as required.
Wheels inside the mast to adjust.
Airspeed. That sounds unlike any propulsion I know. How are these wheels arranged?
The text lays it out. There are 3 wheels located 4 feet up from the pitha, so near the bottom of the mast. Each of these lower wheels is 15.5 feet in diameter and has holes in it.
15.5-foot diameter wheels inside a mast that's 30 feet wide inside at the bottom.
Okay.
Of these 3 lower wheels, the text says the top and bottom ones are fixed solid with bolts. But the middle one, the one in between, is designed to revolve.
How does it revolve?
It's turned by an external key that's fixed on the mast itself.
Oh.
Then there's a second, identical set of 3 wheels, same size, same arrangement, with a revolving middle one located higher up the mast, specifically 44 feet above the pitha, operated the same way with another key.
So you've got these 2 sets of large perforated wheels stacked in 3s inside the mast. Upper and lower ones fixed, middle one spins via a key. And turning that middle one, what did it say it does? Regulates air.
That's exactly how the text describes their function. Turning the middle wheel in each set is the way to regulate or stop the movement of air through the central Nalastamba. This is the system the source details for controlling air or wind inside the structure of the Shakuna.
Internal air manipulation. That's definitely a core part of this design, according to the text. What's right at the very top of this 80-foot mast?
At the very peak of the Nalastamba, the text describes a window dome fixed on top.
A window dome, like an observation dome.
It could be. The dimensions are given. 15.5 feet around the outside, circumference, 5 feet wide inside, and 2 feet high.
Okay. And anything on top of that dome?
Yes. Crowning the dome is another really intriguing component. A sun crystal.
A sun crystal. Just the name sounds significant, like something out of science fiction. Any details on it?
Dimensions are given. It's described as 7 feet round and 2 feet wide and high.
7 feet round, 2 feet high. A sun crystal. You have to wonder what that does. Maybe collecting energy or navigation. We should definitely come back to that when we talk about power.
Agreed. It's a standout feature.
But the inside isn't just this giant mast, right? Does the text mention floors, rooms, that kind of thing?
It does. The description goes on to detail the internal layout. Starting 10 feet up from the bottom pitha, there are 3 distinct floors or tiers built inside the main structure.
3 floors. How high are they?
Each floor is specified as being 14 feet high, and they have floorboards that are 3 inches thick.
Okay, so roughly standard room height, maybe a bit generous. How are these floors supported?
By pillars. The text says pillars are fixed at 10-foot intervals using screw joints again and reinforced with strong bolts.
Pillars and screw joints seem to be a theme. Anything else on these floors?
Yes, it mentions heating yantras in the four corners of the structure on these floors. Each one is described as being 10 feet in circumference and 8 feet high.
Heating yantras. So some kind of climate control system inside the Vimana. That's quite practical. What about people? Where do passengers go?
According to the text, passenger accommodation is on the ground floor of these internal levels. And the description is, well, a bit stark. It says passengers are housed in individual boxes located along the supporting pillars.
Individual boxes. Huh. Doesn't sound very luxurious. But it does show they thought about where people would go. A designated passenger area, even if it's basic. Now, what about underneath all this, down near the base where the mast connects?
Right below the passenger floor level specifically, 10 feet down from it, which puts it 2.5 feet up from the very bottom plate of the pitha, there's what the text calls a cellar-like enclosure.
Okay, a cellar.
This is the space where the base of the mast is fixed, and again, it notes it's secured with firm screw joints. And inside this cellar space, the text places 2 oil tanks.
Oil tanks. How big?
Quite large. Dimensions are given as 15 feet long, 9.5 feet wide, and 4 feet high. And it adds a detail. These tanks have water jackets.
15 by 9.5 by 4 feet. Those are big tanks. With water jackets, like for cooling or heating the oil. Interesting. Anything else down there in the cellar?
Yes. 4 bellows, also quite large, 15 feet long, 2.5 feet wide, and 6.5 feet high.
Bellows. What are they for?
The source actually states their function quite clearly here. They are provided for storing the air pumped in by the air blowers and letting it out as required.
Okay, so oil storage and mechanisms for storing and releasing pressurized air, all located down on the base.
That's what the text describes.
That's really interesting because I think later in the text, when it describes a different Vimana, the Sundara, doesn't it say that one uses oil fumes and steam for motion? Page 96, I think.
That's absolutely correct. For the Sundara Vimana, page 96 explicitly links oil fumes and steam to generating motion.
But here, for the Shakuna, in this section, it just lists the oil tanks and the air bellows as being present in the cellar. It doesn't directly connect them to making the thing fly, does it?
That's a crucial distinction based purely on how the text is organized for the Shakuna's description. The components are listed, clearly part of the design, suggesting they have a function, maybe energy storage, maybe pressure for other systems, maybe linked to those air wheels in the mast. But their explicit role in primary flight propulsion for the Shakuna isn't spelled out right here in this descriptive passage.
Got it. So the parts are there, but the connection isn't made explicit here. One last structural bit. How does this whole massive thing move around when it's not flying? Like on the ground?
For ground movement, the text is very clear. It mentions wheels fixed underneath the structure on all 4 sides, and it gives their size, 7 feet in circumference.
Okay, so regular wheels for rolling on the ground, totally separate from any flying mechanism.
That's presented, yes.
Right. So let's just quickly summarize the structure then. The text gives us this incredibly detailed picture. Huge, complex base plate, pipa. Tall, hollow, tapering central mast, nala stamba, with that weird internal system of rotating, perforated wheels for airspeed control, 3 internal floors with pillars, heating units, and passenger boxes, a cellar underneath with big oil tanks and air storage bellows, and the normal wheels for the ground. It's such a systematic breakdown.
It really is. The text takes this highly structured approach. It lists the parts, gives precise measurements for almost everything sizes, locations, specifies the material, Rajaloha, and sometimes tells you what a part is supposed to do, like the air wheels or the bellows. It blends structural bits, environmental controls, what look like energy or pressure systems, and practical ground mobility. That constant drumbeat of precise measurements is really a defining feature of this description.
Okay, let's pivot from the structure to the substance. The text insists the Shakuna and the other Kataka types must be built from Rajaloha. Let's dig into that. What more does the source tell us about this king metal?
Well, as we've said, Rajaloha is positioned as the essential building block for these Kataka Vimanas, including our Shakuna. Sutra 5 on page 90 makes that clear, and it's repeated on page 91 for the Shakuna itself.
Does the source describe its qualities? Like, why use Rajaloha? What's special about it?
Yes, page 90 gives a definition. It describes Rajaloha using 4 specific adjectives. It must be pure, golden-colored, tensile, and mild.
Pure, golden-colored, tensile, and mild. Okay, golden-colored is aesthetic, maybe. Tensile sounds useful strength under tension. Pure is straightforward, but mild. What do you think that means? Maybe easy to work with? Ductile.
That's a good possibility. Mild could certainly imply workability or perhaps resistance to corrosion, or maybe a specific type of metallic property understood differently then. The text doesn't elaborate on mild, but it gives us those 4 key characteristics.
And the big question, does it say how to make this stuff? Is there, like, a recipe?
Oh, yes. And this is where the text goes into absolutely fascinating, almost bewildering detail. It reads much more like maybe alchemy or some kind of highly specialized lost material science than standard metallurgy as we know it.
Really? Give us the details.
Okay, so to make Rajaloha, the text specifies mixing equal parts of 16 different metals.
16 in equal parts. What kind of metals?
It lists many of them on page 90. You've got familiar ones: gold, copper, lead, tin, iron, brass, but then also manganese, mica. Wait, mica isn't usually considered a metal in the same way, is it? More like a silicate mineral.
Right. Interesting it's on the list. What else?
It continues with things like metals of Soma class, magnetic iron, white lead, zinc, bronze, something called kakara and kanta. It's a long list on page 90.
Metals of Soma class.
Yeah.
Kanta, kakara. Those aren't on the periodic table. So it's a mix of known elements, maybe alloys like brass and bronze, minerals like mica, and these other named substances the text treats as metals. 16 of them.
Exactly, in equal parts. But that's not all. You don't just mix the metals.
What else goes in?
This mixture of 16 metals is then combined with a whole list of other specific substances.
Okay.
The text lists many of these too. Centaur, that's usually cinnabar, mercury sulfide, or maybe red lead oxide.
Most toxic stuff.
Borax, sulfuric acid, nitric acid, mercury itself.
Acids and mercury mixed in.
Wow. And then things like Swarnaksheeri, that sounds almost botanical, doesn't it? Panchamuki Jiraka, which is cumin usually, and various other ingredients, again, from that detailed list on page 90.
Okay, hold on. You're mixing 16 metals, including obscure ones, with minerals, potent acids, mercury, and maybe even plant extracts like cumin. This is way beyond just making an alloy. It sounds like a seriously complex chemical or alchemical concoction.
It absolutely does. It presents this very systematic recipe, even if the ingredients and the whole process sound incredibly unfamiliar, maybe symbolic, or just plain dangerous from a modern perspective.
Is there more? Does it say what to do after mixing all this stuff together?
Yes, there's a purification process described. This involves using specific acids, the source names them as Dara and Sarashtra acids, and then putting the mixture through repeated heating cycles.
More acids and heating.
And the stated goal of this whole complicated procedure, mixing the 16 metals with all the other stuff, then purifying with specific acids and heat, seems to be to achieve those 4 qualities mentioned earlier.
Purity, golden color, tensile strength, and mildness.
Exactly. To produce the final Rajaloha with those specific characteristics needed for building the Vimana.
It's just wild how the text goes into this level of detail. Not just use strong metal, but use this metal made this way, with these ingredients and this purification. Does it give any context for metals in general? Like, where do they come from in the world of this text?
It does touch on that, yeah. On page 16, it offers a kind of theoretical background for the origin of metals more broadly.
What's the theory?
It presents this idea that metals originate due to gravitational forces. Not just Earth's gravity, but gravity from the Earth's core, the sun, the moon, the planets, specific stars, and even the universe as a whole.
Gravity from planets and stars creates metals.
That's the idea presented. These various gravitational forces, acting in specific proportions, combined with heat and moisture found within the layers of the Earth, are described as the catalyst for the formation of different metals, including those Soma-class metals mentioned in the Rajaloha recipe.
Wow. Okay, that adds a whole cosmological layer to their material science, doesn't it? Metals formed by cosmic gravity plus Earth heat and moisture. It's such a different way of thinking about the fundamental nature of materials.
It really underscores how comprehensive the knowledge system presented in this text claims to be. It's not just about building the machine, it extends to the very origins and intricate preparation of the substances you need to build it with.
So we've got the structure, incredibly detailed. We've got the material Rajaloha with its complex, almost alchemical recipe and cosmic origin story. Now the big question, how is this Shakuna Vimana supposed to actually fly? What does the source tell us, or maybe just hint at, about propulsion and control?
Okay, propulsion. Based on that detailed description of the Shakuna on pages 91 and 92, we can point to several components that seem related to movement or control. But, as we've said, the main power source isn't quite as explicitly spelled out for the Shakuna as it is for, say, the Sundar Vimana later on.
Right. So what do we have for the Shakuna?
Well, a key system we talked about is inside the mast, the Nalastamba, those 6 wheels.
The ones for adjusting airspeed.
Exactly. The text explicitly says their purpose is in order to adjust the airspeed as required. Now, it's not described like, catching the wind like a sail. It seems to be an internal system for manipulating air currents or flow within the mast itself.
So maybe that affects lift or stability or somehow directs the craft.
It's hard to say definitively from the description, but it strongly suggests that controlling air inside the mast is fundamental to how the Shakuna operates, according to this source's framework.
Okay, internal air control via mast wheels. What else? What about that sun crystal sitting right on top? That sounded important.
It certainly sounds it. The sun crystal fixed on the dome at the apex is another major clue towards a potential energy source or control system.
Does the Shakuna description itself say what the crystal does?
No, not really. The description on page 91 just says it's there, gives its dimensions, 7 feet round, 2 feet high wide.
Yeah.
But the broader text of the Vaimanika Shastra gives us more context.
Ah, okay. What does the rest of the text say?
Elsewhere, on page 10, there's a list of 32 different mechanical contrivances for Vaimanas. Number 28 on that list is a solar power attractor at the top of the Vimana.
A solar power attractor. That sounds like a direct match for the sun crystal's location.
It does, doesn't it? And there's more. On page 29, the text describes a specific device, a yantra, called the Surya Shakti Pakarshana Yantra.
Surya Shakti. That sounds like sun power.
Exactly. It translates as collector of solar energy. Now, this yantra is described as being used in another system in the text, something called the universal reflecting mirror, but the description involves a crystal.
A crystal used to collect solar energy.
That's what it implies. The text says, regarding this other system, that 8 parts of sun power and 12 parts of electric power should be passed through the crystal into the mercury.
Whoa. Sun power and electric power channeled through a crystal into mercury. That's advanced.
It certainly sounds it.
So if we connect the dots, the Shakuna has a sun crystal on top. The general list of parts includes a solar power attractor, and another section describes a solar energy collector yantra using a crystal to channel sun power and electricity into mercury. It really makes it seem like the Shakuna is intended in this text to use solar energy, right? Captured or processed by that crystal.
That seems like the most logical conclusion you can draw by piecing together those different parts of the text. The sun crystal on the Shakuna looks very much like it's meant to capture or interact with solar energy. How exactly that energy then makes the Vimana fly? Well, that specific mechanism isn't fully laid out in the Shakuna's own description. The text gives us the component and strongly hints at the energy source.
Okay, so internal air control and likely solar power via the crystal. What about those big oil tanks and the air bellows down in the cellar? Did they have a role in flight?
Well, as we discussed when looking at the structure, the Shakuna description on page 92 definitely includes them. 2 large oil tanks with water jackets, 4 large bellows for storing and releasing pumped air. Their presence means they're part of the system. But unlike the Sundar Vimana description later on page 96, which explicitly says oil fumes and steam create motion, the Shakuna description doesn't make that direct link for its oil tanks and bellows.
So they're there, but maybe they're for something else. Powering auxiliary systems, generating pressure for the air wheels, maybe storing energy collected by the sun crystal somehow.
Those are all possibilities consistent with the text just listing them as components without specifying a primary propulsion role in this section. Their exact function in the Shakuna's flight remains a bit ambiguous based solely on this part of the source.
So it feels like the text gives us these different puzzle pieces. For the Shakuna's power and movement, the internal air wheels in the mast, the sun crystal pointing strongly towards solar energy use, based on other parts of the text, and these stored oil and air pressure systems in the base. But how they all fit together to actually lift off and fly, the text leaves some gaps in this specific description.
I think that's a fair summary. The source provides this inventory of sophisticated-sounding components. It tells us where they go, sometimes what they immediately do, like regulate air, store air. We then have to infer or interpret how they might combine for flight based only on what's written for the Shakuna, maybe cross-referencing with other parts of the text where concepts like solar collection are explained more.
And it's really important to stress again, isn't it, that despite the name Shakuna meaning bird, The detailed textual description of its mechanism on pages 91-92 does not include flapping wings.
Absolutely critical to reiterate that. The description focuses on the mast, the internal wheels, the potential solar connection, the bellows, etc. It does not describe ornithopter-style flapping for propulsion for the Shakuna model.
The text does mention wings and flapping elsewhere, doesn't it? But not for the Shakuna's flight.
That's right. Page 82 talks about plane wings and flapping, but it's specifically in the context of something called the Stambana yantra, a device used to make a Vimana stop or become stationary. And it's discussed in relation to the Tripura Vimana, a different model. It's not presented as the Shakuna's primary means of flying.
So stick to the text for the Shakuna. No flapping described for flight. It's almost like the bird name is maybe symbolic or refers to its overall shape, perhaps, but the tech described inside is something else entirely.
That's one way to interpret the discrepancy, yes. The name suggests one thing, the described mechanics suggest another.
Okay, so we've pulled apart the structure, the materials, the potential power and control systems as described in the text. Why does doing this matter? Why spend time deep diving into the Shakuna Vimana description from this specific, maybe controversial text? What's the point for us and for you listening?
Well, I think it matters because, first of all, this document exists. It's a remarkable thing in itself, and it tells us a lot about human imagination, doesn't it? About this seemingly age-old cross-cultural fascination with flight, with really advanced technology.
Yeah.
And regardless of all the debates about its historical authenticity, whether the text is truly ancient or a more recent creation channeling older ideas, the Vaimanika Shastra as a document is incredibly complex. It makes these huge claims, and it tries to describe deeply intricate technical concepts.
Like the detailed structures, the Rajaloha recipes, the proposed mechanisms.
Exactly. And it does all this within its own distinct philosophical and cultural framework, linking technology to cosmic ages, to specific types of knowledge like mantras or tantras or mechanics.
And it's the sheer level of detail that really grabs you, isn't it?
Absolutely. I think that's where the real value of exploring it lies, the granularity of the description, the specific measurements, 80 feet here, 15.5 feet there, 3 inches thick, the listing of all 16 metals and the acids and the mercury for Rajaloha, the precise layout and stated function of things like those internal airspeed wheels.
It forces you to try and picture it, to really engage with the ideas being presented.
It does. It invites you to visualize and really ponder what's being described in this unique document. It's like looking through a very specific window onto how complex technical ideas were conceived, categorized, maybe dreamed of, and written down within a particular cultural context. It gives us this singular glimpse into a specific kind of technological imagination and ambition.
Okay, so let's just quickly recap the key takeaways from our deep dive on the Shakuna Vimana, based purely on that 1973 Josir translation of the Vaimanika Shastra.
Right, so the text presents it as a Kritaka Vimana, that means artificial or mechanical belonging to our current age, the Kali Yuga.
Its main building material is specified as Rajaloha, described as pure, gold-colored, tensile, and mild, and made from this incredibly complex recipe involving 16 metals, acids, mercury, and other stuff, all mixed and purified in specific ways.
We unpacked its structure as described, that huge, geometrically specific base, Pitha, the tall, hollow central mast, Nalastampha, with its unique internal wheels for adjusting airspeed, the internal floors with heaters and passenger boxes, the cellar below holding large oil tanks and air storage bellows, and the normal wheels for ground movement.
And we looked at the clues for propulsion and control. That internal air control system in the mast seems key. The sun crystal on top strongly suggests solar power, especially when linked to other parts of the text describing solar collectors. And the oil tanks and bellows are there, clearly important, but their exact role in the Shakuna's flight isn't explicitly detailed in its main description.
Yeah, it's this document that just fascinatingly blends these two things.
Right.
On one hand, you have almost obsessive engineering-like detail lengths, widths, heights, diameters down to the foot and inch. And on the other hand, you have materials and energy sources that are described using terms and processes rooted in the system of knowledge presented as ancient, often operating outside our current scientific paradigms.
Which leads us nicely to a final thought for you, our listeners, to maybe mull over. The Vaimanika Shastra, through descriptions like the one we explored for the Shakuna Vimana, it paints this picture of an alternative technological history, doesn't it? A world where ancient wisdom supposedly included not just philosophy, but the blueprints for complex machines like flying craft, built from unique materials like Rajaloha, powered by energies hinted at through things like a sun crystal. So what does the sheer ambition, The intricate detail found in a text like this, claiming ancient knowledge of how to build these things, down to the parts, dimensions, and material recipes. What does that tell us about, perhaps, the boundless nature of human imagination? Our constant fascination with flight, our drive towards technology, however it's conceived in different times and cultures.
It's a document that's undeniably there. It challenges typical historical narratives, and it really invites you, doesn't it, to think about all the different ways human ingenuity, whether it was real or imagined or a mix, has been dreamed up and meticulously recorded throughout our history. Something to think about.